Hello and welcome to another section in further mathematics. In today's section, we'll be looking at application of a vector product. But before we move further into what we have today, I'd like us to do a quick review of our last lesson. Okay, welcome back. Now, I said today we'll be discussing on application of vector product. Now, when we talk about application of vector product, we want to apply the concept that controls the vector product into looking for series of areas, volume of shapes, and so on. Now, I'd like us to apply it. Let's apply it and look for the area of a parallelogram. I will be looking for the area of a parallelogram. I will also prove the area of a triangle. I would like us to apply it into looking for the area of a triangle. I think these two is very okay. Okay, now let's go straight into getting the area of a parallelogram. Remember, a parallelogram is a shape of this form. Parallelogram is a shape. Okay. Okay. Okay, this is the shape of a parallelogram. Let's call here point O, call here point B, let's call here point A, and call here point C. Now, if we want to look for this area, let's call this point theta, and we have to project this down and call here our H. Okay, in having this, we want to prove and knowing fully well that the area of OAC, that is OAC of this is equal to, and these values are A, is equal to a height H over, and here is our B, sorry, is equal to a H over B. And the value of a H over B can be stated as value of H over B, which is H, and here is equals this, so you now have A absolute, then sine theta B, because of this distance and the angle that is being involved. Now let's take these terms together. It becomes A B sine theta. So, and remember we stated that A cross B sine theta is equal to A cross product of B, the absolute value. So in application, if you want to look for area of a parallelogram using vector, just look for the cross product of the two sides of the vector. So the cross product of A of sides, the cross product of sides of a parallelogram is the same thing as its cross product. Now let's do that of a triangle. We call that one example 2. Area of a triangle. But first, let's get the shape of our triangle. If this is our triangle, wow, we call this point, and let's call it point A, call this point O, B, the same distance. But remember, you can't look for an area of a triangle without bringing out the shape. So in bringing out the shape, this is H, which happens to be the height. Then these are small b and these are small a. So area of angle of triangle, area of triangle OAB is equal to, remember, half, but the base is now this, times height. Half base times height. This is the rule. Now, which is the same thing as half. Then you know the value of our height is a, so our theta should be here. The value of our height should be equals p product a sine theta. But don't forget that we stated earlier that a b sine theta, just like what we proved in that of a rectangle, is equal to cross product of a times b. So we now have this as equal to half a b sine theta, which is the same thing as this, a cross b. So therefore the area of a triangle is equal to half a cross b. So I would like to say this is just a brief application into the use of vector product in looking for the area of shapes. So we can also do that looking for the area of a square, the area of a rectangle. But I would like to say a very big thank you for joining us in this lesson. Now, in order for you to refresh your memory on what we've just discussed, please always take the test that appears on your screen. Do well to use the lesson notes on the projected topic for better information on the topic we've discussed. Thank you.